Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about exponents for business. In business, you're going to encounter formulas that have exponents, and you're going to need to know how to work with those exponents. Prime example is this compound interest formula. So I want to talk about the rules of exponents, and then I really want to focus on how you can use your calculator to do all of the calculations when you're working with exponents. The first rule deals with the product of two powers. So you have y to the exponent of a times y to the exponent of b. As long as the bases are the same, you can multiply those two powers by adding the exponents. So for example, if I had x cubed times x to the fifth, that would be equal to x to the 3 plus 5, which is 8. And you can understand that if you think about what x cubed means. It means x times x times x. X to the fifth means x times x times x times x times x. So you're multiplying x to itself 8 times, which is x to the 8th. The second rule deals with the quotient of two powers that have the same base. So y to the a divided by y to the b will be equal to y to the a minus b. For example, if I had m to the 11th divided by m to the 6th, that would be equal to m to the 11 minus 6, which would be 5. If you had this example, t to the 6th divided by t to the 8th, that would be equal to t to the 6 minus 8, which is negative 2. And we're going to define what a negative exponent is in just a few minutes. Third rule says that if we have a power and raise it to another exponent, the way that we can simplify that is just multiply those exponents. So y to the b to the a will equal to the y to the b times a, or a times b. For example, if I had z cubed and then that was squared, that means z cubed times z cubed. We know that we add those exponents, 3 plus 3, which is 6. Or according to this rule, 3 times 2 would be 6. So we don't have to do that intermediate step. The next rule says that if we have a product raised to an exponent, we can apply that exponent to each factor in that product. So this would be equal to y to the a times z to the a. So for example, if I had x squared y to the fifth, that would be equal to x squared to the fifth power times y to the fifth power. And we already know that x squared to the fifth power would be x to the 10th times y to the fifth. Next rule states that if we have a power and the exponent is equal to 0, then that result will equal 1. And the best way to show why that's true is if I had, let's say, x to the fourth divided by x to the fourth. We know anything divided by itself is equal to 1, so we know that this is equal to 1. And according to rule number 2, with our rules of exponents, we know that x to the fourth divided by x to the fourth will be equal to x to the 4 minus 4, which is equal to x to the 0. So it kind of shows you why a base raised to the power of 0 is equal to 1. It doesn't matter how complex your base is. This whole thing is raised to the power of 0. That's all we care about. It's equal to 1. This next rule is often one that causes a lot of difficulty. When you have a negative exponent, so y to the negative z, it's equivalent to 1 over y to the positive z. So for example, if I had x to the negative 3, that is equivalent to 1 over x to the 3. And one way that I can maybe show you that that's true is if I had x squared divided by x to the fifth, we know that that's going to be, according to rule number 2, x to the negative 3, 2 minus 5. If I wrote x squared out as x times x, and I wrote x to the fifth out as x times x times x times x times x, this factor of x would cancel, this factor of x would cancel, and I'd be left with 1 over x times x times x, which is x cubed. So you can see that those two things then are equal. The last rule also causes difficulty. If you have a base to a fractional exponent, you have to understand that that involves roots. So y to the power of a over b would be equal to the b root of y to the a. So for example, if I had x to the 1/2, that means the square root, and when we write square root we don't have to put the 2 in there, of x to the 1. So x to the 1/2 would be square root of x. If I had m to the 2/3, that means it's cubed root of m squared. It's important to understand the rules of exponents, but it's even more important to know how to use your calculator to find different values raised to different exponents. So that's what I'd like to focus on now. Whether you're dealing with whole number exponents, negative exponents, or fractional exponents, you're going to use this function on your calculator, y to the power of x. So our first example, 5 cubed, you always enter the base first, then you press your y to the x key, and then you press your exponent, and then equals, and in this case you should get 125. If you have a negative exponent, again put the base in first, y to the x. To enter a negative number you have to put the number in first, and then you make it negative by pressing your change sign key, and then press equals. So 4 to the negative 2, you should get 0.0625. So your calculator will know that 4 to the negative 2 means 1 over 4 squared, or 1 over 16, but it does it in decimal form. Our next example is 8 to the 1/3, which we know according to our rules of exponents is the cubed root of 8. And to do that on your calculator, enter your base of 8, then enter y to the x, and then you need to enter 1/3. It's very important that you use brackets to express 1/3 as 1 divided by 3. If you don't use the brackets, it will be wrong, because what your business calculator will do, it will take 8, raise it to the power of 1, and then take 8 and divide by 3. That's not what we want. We want to raise 8 to the power of 1 divided by 3. So we are using brackets to force your calculator to do the division and then the exponent. And we should get a value of 2. So just try that on your calculator. Same idea if we have 8 to the 2/3. We know that that means cubed root of 8 squared. So to find that with your calculator, enter 8, y to the x, 2 divided by 3 with the parentheses, and you should get a value of 4. If you didn't, you may have forgot your grouping symbols. Let's throw a negative and a fraction, but don't worry, we're going to let your calculator do all the work. We know that what that means is 1 over 8 to the positive 2/3, and what that then means is 1 over cubed root of 8 squared. But we don't have to go through all that. We can let the calculator do the work. We're going to enter the base, y to the x, and then we're going to enter 2 divided by 3, make it negative, and then equals. You should get 0.25 as a result. So it doesn't matter how complicated the exponent is, as long as you're aware of order of operations and you know how to enter it into your calculator using your y to the x key, you can let your calculator do all the work. Now let's take a look at this example that I had at the beginning of the video, and now that we know how to use our calculator, let's evaluate it. It's important to remember order of operations. We do what's within the brackets first. We do division before we do addition. So 0.04 divided by 4 will be 0.01. I add those. Then according to BEDMAS, I do my exponent first, and then I do multiplication. So let's take 1.01 and raise it to the power of 8. 1.01 raised to the power of 8 will equal 1.0829. And now I can multiply that by 1,000. Using the value on my calculator, not this rounded off value, I will get 1,082.8567 rounded off to 4 decimal places. And if you have your business calculator in AOS format rather than chain format, which means it follows the order of operations or BEDMAS, you could go 1000 times 1.01 y to the x, 8 equals, and you should get that value. So hopefully now you know how to use that function on your calculator to find values raised to any exponent, whether it's whole number, negative, or fractional. Just remember to follow your order of operations when you're doing these calculations.